This is question number 9. Let me write the question down. The first term of a progression is cos theta, and theta is lying between 0 and pi over 2. So the first term is cos theta. Question A is, for the case where the progression is geometric, the sum to infinity is one over cos theta. Now what they are asking us is show that the second term is cos theta times sine square theta. Okay, that's the first part. Now let me start off with the first part. Okay, for the case where when the progression is geometric, the sum to infinity is given to be as 1 over cos theta. Sum to infinity for a GP, right, that is given as a over 1 negative r, where a is the first term, where a is cos theta, because it's given already. The first term is cos theta. Right. Also, sum to infinity is given as 1 over cos theta. Right. So this means I got 1 over cos theta is equal to cos theta divided by 1 negative r. So you cross multiply, you would get 1 negative r is equal to cos theta into cos theta is cos square theta. You move cos square theta to the left and you move r to the right. So this will give me 1 negative cos square theta is equal to r. Right. So this means r is equal to sine square theta. This is the ratio, the common ratio. So to get the second term, you take the first term and you multiply with the common ratio. So what is the first term? First term is cos theta. What is the common ratio? Sine square theta. So therefore the second term is what? Cos theta times sine square theta. Hence proved. Okay. So let's move on to the next part. Now this is the second part of the question. The question is as follows. Find the sum of the first 12 terms when theta is equal to pi over 3, giving your answer correct to 4 significant figures. Right. So the sum of the first 12 terms. So what is the formula? We have a formula for that, right, which is Sn is equal to a times 1 negative r raised to the power of n over 1 negative r. This is the formula. Now what is the first term? First term is cos theta. And what is theta? Pi over 3. So therefore a is equal to cos pi over 3. What is cos pi over 3? That's going to be cos 60. And what is cos 60? 1 over 2. So therefore the a value is 1 over 2. Now we can also calculate the value of r. Now r is sine square theta, right? So that means at theta is equal to pi over 3, this is going to be sine squared of pi over 3. Now this is going to be root 3 over 2 whole squared, because sine 60 it is. Sine 60 is root of 3 over 2. So substitute that, that would give you 3 over 4. So this is my r. Now we need to get the sum to infinity, right? So Sn is equal to a times 1 negative r raised to the power of n divided by 1 negative r, and our a is 1 over 2 times. Now we are looking for n to be equal to 12. So substitute that. So this is going to be S12 is equal to 1 over 2 times 1 negative 3 over 4 raised to the power of 12 divided by 1 negative 3 over 4. This can be evaluated as 1 over 2 times. Now you can use a calculator. If you were to use a calculator, this value 3 over 4 raised to the power of 12 is approximately 0.03168. You can substitute that. So 1 negative 0.03168 divided by, and you can simplify this. So this is going to be 4 negative 3 over 4. So you flip that, that would give you 4 over 2. 4 negative 3 is 1. So 4 over 2 times 1 negative 0.03168. This is what you got. So 2 divides 4 2 times. So 2 times of 1 negative 0.03168. So if you were to use a calculator, you would approximately get S12 to be as 1.937. Okay, so that would be the value. Now the next part is we have to find the arithmetic sequence. So find the 85th term. So the next part is find the 85th term of AP for theta is equal to pi over 3. Now we all know a value we have already substituted. That's the first term, so cos theta. So therefore a is equal to 1 over 2, that is got, right? AR is the second term, and let me write that second term. Second term is actually cos theta times sine squared theta. We got this, right? Because I don't want to write it AR because AR comes for GP, but we know how to get the second term, and we got the second term in this fashion. But theta is equal to pi over 3, so that means cos theta we already got, that's 1 over 2, and in this case this value is going to be root 3 over 2 whole square, which is going to be 3 over 2 squared is 4, 4 times 2 is 8. So this is my second term, but we need to get the value of d, so therefore d is going to be 3 over 8 negative 1 over 2, right? So if I were to take the LCM, this is going to be 3 negative 4, which is going to be negative 1 over 8. So this is my d. Let me write that down. So d is equal to negative 1 over 8. Okay. So we got a value, we got the d value. Now we need to get the 85th term. So let me go to the next slide. So suppose Tn is equal to a positive n minus 1 into d. This is the formula we use. So we are talking about the 85th term. So T85 is equal to, the first term is 1 over 2, 85 negative 1, and the common difference is negative 1 over 8. So this is what we have got. So this is going to be 1 over 2 positive 85 negative 1 is 84 times negative 1 over 8. So 4 divides here 2 times, 4 divides here 1 time, 4 divides here 2 times. So this is 1 over 2 negative 21 over 2, right? Now if I were to take the LCM as 2, this is 1 negative 21, which is negative 20 over 2, which would give us negative 10. So therefore T85 is negative 10. So that's a solution for this question. So we have done this well. We move on to the next one, students.